All right, okay, let's finish this up. Class?
Yes.
All right, thank you people for showing up today. I appreciate you for showing up, okay, even though you're super late. Now, today we're going to go over and I'm going to tell you this is on the test. This is on the test right here. So I'm going to help you out. So, range in interval notation. So if I think about it, for certain things, it says sine and cosine. So the range would be the y values. Okay? So if I think about my values as I go around my circle, it's always going to be, we haven't actually even done the unit circle yet, have we? No. So
No.
tools, insert, page. So, there we go. All right, so these things have my values. All right, so this is actually the basis of a unit circle. It's a circle, right? Anyone guess what the radius is? 1. Right? From the center out to any point on the edge of the circle is always going to be? It's always going to be?
1.
Okay, so now if I'm looking at this, the range of any function that's on this circle, that's going to be the y value. What's the highest y value I'm going to have here? 1. It's not going to go, can't, right? Because it goes here. So the highest point's right here. So my range would go up to 1. What do you think the lowest point of my range is? -1. So the range of this is going to be inclusive between -1 and 1. And that's going to be sine and cosine. It also works for tangent too. But there's also some intervals that are not allowed because isn't tangent y over x? Say yes.
Yes.
Y over x. So what can x not be?
0.
X can't be 0. Why?
Because you can't divide things by 0.
Can't divide by 0, right? So in that case, and this is sine and cosine, but tangent is going to go from, okay, it
Just not a single one that has 0 as x, right?
can't have, so it can't have 0 in the denominator, right?
Yeah.
So the tangent would mean that it would go from y over x, so my range would start at, okay, the lowest point is going to be what?
0. Oh, like what? Like on which one?
Okay, so it would go, the lowest point would be down over here, but can it do that?
No.
Can I have y over x right there?
Because that's 0.
No, so it's going to be slightly different. So down here at the bottom, it would be parentheses, -1. Why is it parentheses instead of bracket? What's the difference between the parentheses and the bracket? Why you keep looking at Denny? He ain't got all the answers. Go ahead.
I'm not for sure, but the bracket means that it's only that, and could be like other points.
Super close, super close. The bracket means it's inclusive. So it means that point, everything up into that point, and including that point.
Oh.
Where parentheses means everything up to that point, but it cannot be that point. Because what happens if I'm down here at the bottom? If I'm down here way at the bottom and I get 0 down here, then x is 0, right? Okay, can the x be 0? Say no. But it can go really close to it, can it? It can go really close to it, but it can't be that number. So it's going to go from there, so it can't be that number, and it goes to +1. So these are my ranges, and then let's talk about domains. Did my slide have domain also? Range. I don't know. It didn't have domains. So, yeah. I'm not going to worry about these ones on the bottom yet, because until we start working with the calculator. You'll see why on those ones. Now, calculator. Everyone has a calculator in front of them, right? Yes. What mode your calculator should be in? Help me out. Come on.
Rad.
Are we in rad? Have we done anything in rad yet?
Degrees.
Everything's in degrees, isn't it? So, your calculator should be in degrees. So we're going to do degrees, right? Okay. So, a couple of these things. Now, I don't know if you guys remember this from your algebra, blah, blah, blah. Let me see. Your algebra class, whichever class you decided to learn it in, or geometry. Okay. If I'm looking for theta, is there something I need to do? If I'm looking for the angle, there's something I have to do. Anyone? I know you guys actually did it because I know your teacher. Yes.
Inverse.
Huh? Very good. Inverse. If I'm looking for an angle, I do the.
Inverse.
So whenever I'm looking for the angle, I do the.
Inverse.
Everyone should say, hey, I'm looking for the angle, I need to do the.
Inverse.
Every single time. You're going to hear that so often. Everyone's going to be doing the inverse. Now, I'm going to rewrite this with the inverse. So I'm going to say that theta is equal to inverse sine of 2.5. Try it. That means have your calculator on. Plug it in. What mode are you in?
Degree.
You're in degrees. You have your scratch pad open. You are plugging this into the calculator. Where do I find the inverse sine at?
Is it gonna be in the book?
Nope.
No.
You could find it there, but it's easier. It's on the left-hand side. Trig.
Oh.
Hit the button that says trig. So hit the button that says trig, and then you can select which one you're going to do. It says what?
Undefined.
Undefined. So if that's... Didn't get him that time. If it's undefined, is that possible or impossible?
It's possible.
It's what?
It's impossible.
Impossible because it's
Undefined.
undefined. Very good. Is that super easy?
Yeah.
That is super easy, isn't it? So if I'm following along, I put it in my calculator, I double check it, I'm looking for my angle. Now, let's try and do it by hand. Do we know what sine is? What does sine represent? Y over R. So I know you're not shaking your head at me because it's in the notes from 1.3, right? You know those tables?
Yeah.
On 1.3. If you don't have those ones down by now, you got to get those. Sine is Y over R. But do I have a fraction here? No. Can I make it into a fraction? What is the one thing I could do to any number to make it into a fraction? Put it over what? Make it a fraction by putting it over 1. Does that change the value? No. 2.5 divided by 1 is still 2.5, isn't it? So let's take a look. So if I rewrite that and I say 2.5 over 1, now what do we know so far? We know that R represents what? The radius of a triangle, right? Or the radius of that circle. And in a triangle, my radius would be from like here to here. And it makes a triangle like this. This is my radius, this is my y, and this is my x. What theorem uses this? Pythagorean theorem, right?
Yes.
Okay. What do we know about the Pythagorean theorem? seriously. I would rather people guessing than actually just sit there and stare at me awkwardly. Very good. A squared plus b squared equals c squared. So what do you think about the c? If it's a squared plus b squared is equal to c squared, what do you think about the c? It's what? It is a radius, and it should be the longest side, shouldn't it? Because if it's a squared plus b squared is equal to c squared, I know that c has to be the longest side. And then this right here, what represents c? My r, right? The r has to be the largest side, doesn't it? The r has to be the largest side. Which one's the largest side? The r is my largest side every time, right? It's always going to be the largest. And what else do we know about the r? It's always positive, right? So let's go back and look at this problem. Do we see a problem here? Which one's bigger? Is the y or r bigger?
The R's gonna be bigger. Oh, and the actual thing is, yeah.
Yeah, the y is bigger than the r. So is that possible?
No, because it's R supposed to be bigger.
R is supposed to be bigger, so I would say that is impossible, right?
Yeah.
That's how we do this by hand. So you can check it on your calculator if you're uncertain. So I want to give you more than one way to do it. And then this one right here, we could say, hey, it's impossible. Now, how about that tangent theta? What do we know tangent represents?
That was wrong. Y over X, no?
Y over x? So if you guys are getting lost, hey, have the little slide out in front of you. Tangent, where's that from? 1.3 is where we have all that tables, right? 1.3. So we're going to keep referencing this, and that's why I keep telling you over and over again. The things you have to know is x, y, and r. Always x, y, and r. We're going to do this a lot with your x, y, and r. So tangent theta is y over x. And can I write this number as a fraction? 110.47, can I write that as a fraction? I would put that what? Over 1. So in this case, my y value is 110.47 and my x value is 1. Is that possible or impossible? What do you know about your triangle? Which one's the biggest? R. That's all you know, right? Does it say anything else about the x and y? No. I know that it would be, in this case, x squared plus y squared would equal to my r squared, right? But do I have r here? I don't have an r. So do I know a comparison about my x and y? Is there anything special about the x and y? Not that I know of, right? So at this point, not that I know of, so do you think this one's going to be possible or impossible? Let's try possible. Is there another way to check your answer?
Oh, put it in the calculator.
Put it in the calculator, right?
Or you can see if Y is, or if anything is greater than R.
So let's put in the calculator. So theta equals inverse tangent of 110.47 over 1, or if you just want to put it in like that, you can.
I think I got it. I think it's against 1. Nope.
Yes. You don't want to do the problem? You can? Okay, you can go. Fine. You don't need this information. It's not like it's good information. It's not like the greatest information you'll ever learn.
Oh, you actually get an answer for this.
You do. So if you get an answer, that means it's
Possible.
it is possible. Very good. There we go. All right. so let's take a look at secant. Secant, what do we know about secant?
So you get R over X.
R over X, so let's write that out. So it's R over X, so R over X. Now, if I write this as a fraction, this would be over 1, isn't it?
Yeah.
Over 1. Now, what did I say about all these problems? What do we know about R?
It has to be bigger than X and Y.
It has to be bigger than the X and the Y, right? So, is R bigger than the X?
Yeah. Oh wait, hold on. No, it's not.
It's not, is it?
It's impossible.
So this one's going to be impossible. How do I check my answer?
On the calculator.
Yeah, just plug it in. Plug it in the calculator. And if you get undefined, that means it's impossible. So this is impossible. Impossible.
Yeah.
Alrighty. So let's take a look at the next one. Are we okay so far? Okay, good. Now, suppose an angle theta is in quadrant 2. Sine theta is 2 over 3. Find the values of the other 5 trigonometric functions. Alright. So, on this one, we are given sine. What do we know about sine? Sine represents y over r. So I know that my y value is, what's my y value?
2.
My x value is, don't know yet, but r value is, now, we know we're missing something, right? We're missing the x. And if my angle is in quadrant 2, what do we know about the x value in quadrant 2? It's negative. The x value in quadrant 2 is negative. Yes? No? Maybe? Question? Okay, we talked about this one the other day. I wrote out the whole circle. I put in all the different things. So the x value in quadrant 2 is going to be negative. So that's one thing I'm going to put right here. And now this next part is going to go back to what we did in the warm-up. Every single time we've been doing this, we've been using the Pythagorean theorem, right? Pythagorean theorem. But it's x squared plus y squared equals r squared. So I'm going to say that x squared plus y squared equals r squared. Let's plug in x squared plus my y is 2 squared equals r, which is 3 squared. Now that negative is going to come up at the very end. That's why I put it over there where my answers are. Let's do some math. So I get x squared plus 2 squared is 4 equals 3 squared is 9. Subtract 4 from both sides. X squared equals 5. And now x equals, now I didn't do this earlier because I kept everything in quadrant 1 for my problem. But this right here, when I take a square root of something, there's something I have to verify. I have to make sure. Anyone recall what that is? Anyone? What do I have to do if something... Left her present.
She gonna come back. She gonna be like, why did that flag gonna tell me? Not just be.
Yeah.
You had shh. It didn't happen.
It didn't happen.
There we go. It didn't happen. Someone did not get a smash fly in their notebook.
Did you hold it wrong? You dropped the ball.
I know. Only if she goes back and watches this video, she'll be like, what? What are they talking about? Okay. All right. So we always have to remember that there is a possibility for there to be a positive or a negative. Whenever I'm doing this, and I'll show you why. So plus or minus this square root. Oh, that should be like this. Plus or minus square root of 5. You'll see here in a second why. So, if I'm plugging in a value for this, and it says, so let's say x is positive or negative. So, dang it. And in my formula, I have that x squared is equal to 5. Yes? I'm trying to prove this right here. So this isn't a step you have to do all the time. I'm just proving it for you. So let's go ahead and check it. So if it's radical 5 squared, is that equal to 5? What happens when I square square root? It cancels out. So will that become a positive 5? Yes, it will. So here 5 equals 5. But now let's try the other side. So let's say that it's now negative square root of 5 squared. Is that equal to 5?
I don't think so.
You don't think so? What happens when I square a negative? When I square something, isn't that just multiplying that number times itself? So isn't that the same as saying negative radical 5 times negative radical 5, isn't it?
Yeah, it's the same thing though.
A negative times a negative gives me a,
Positive.
there we go. And so it's now going to become a positive, and what's going to happen to that radical?
It's gonna be gone.
So I still get 5 equals 5. So that's why there's always a possibility for it to be a positive or a negative. They're possibilities, so that's important. They're possibilities. Now, in this case right here, because we start off that my theta is in quadrant 2, I know my angle or my x value has to be negative, right? And that's why I started this off. So negative radical 5. So now we're going to go through and fill in all my values with this. As long as I'm not doing my makeup right now, I might get a finger in my eye for doing that. So let's go ahead. So we already had sine. So next one is cosine theta. So from the 1.3, x, y, and r. You're going to use that table so often, that x, y, and r. So cosine is x over r. My x value was negative radical 5 over 3. Tangent theta. Tangent is y over x. Tangent is y over x. So my y value is 2. My x value is negative radical 5.
And that's where you gotta rationalize it. So you multiply it by negative rad 5 and over negative rad 5. So it would be what, like I don't even know.
Yes, you do.
It wouldn't even be 2 negative rad 5. Yeah.
So negative 2 rad 5 over.
Be like 1.
So serious question. What is rad 5 times rad 5?
Rad 5 times rad 5 is
Rad 25. What's 5 times 5?
rad 25.
Very good. What's the square root of 25?
5, so it should be 5.
It's just going to be 5.
That's why I was confused.
There you go. Yeah. And if he knows the two negatives will make that positive, and all it did is it moved the negative up to the top. So when I rationalize, do I have to use the negative? No. I don't have to use the negative when I'm rationalizing. Okay? Positive or negative, it's not going to matter. But if it's two negatives, it will cancel out anyway. So if this 2 was also negative, that would cancel that out. It would make the whole thing positive. So let's do cotangent now. So what does cotangent represent?
Cotangent.
Is what?
X
X
over 1.
of y. My x is negative radical 5. My y is?
2. That's fine like that, right?
Sure. Just like that. No problems there. Next one is going to be cosecant, so CSC theta. What does cosecant represent? R over y. So my R is
33 over 2.
and over 2. Very good. Secant. Secant is R over x, right? R over x. So my R value is 3. My x value is very good. So again, same thing. Rationalize. Rad 5.
It's going to be negative 3 rad 5 over 5.
Very good. Next one is that all of them? Yep, that's all of them. Because we were already given sine in the first place. Is this easier?
Yeah.
Hopefully it's getting easier because we keep doing the x, y, and r over and over and over again. Where are we at? I think we're way over here. Okay, here's the different Pythagorean identities. I'm not going to worry about these now. When we get into it later on, you will understand more about this. So, don't worry about it. Don't worry about it. Now, example 6 is the same thing that we just did on example 5. They try to make it more confusing when all you need to know is your x, y, and r. So cosine theta, what do we know cosine represents? Say it, what is cosine? X over r. So I know my cosine, so x is going to be what value?
Is it going to be negative root 3 rad, or negative rad 3?
Why would it be negative?
Because there's 3 right in front of the fraction.
Okay, but why would that be negative?
I don't know.
What does cosine represent? R can't be negative. R can't be negative. So where does the negative have to go in this one?
To negative rad.
It goes with the x value, isn't it?
Yes.
Okay. And so that means my R is 4. And my y, the only thing I'm given is sine is greater than 0. Sine is greater than 0. So if I think about that, sine is greater than 0. What do we know about sine? What does sine represent here?
A positive number?
It is going to be a positive number. Very good, right? So it is going to be a positive number.
Thought you meant.
I hit that fly. That thing just like straight up benched that thing. Man, he's at sight. He's a what? He's a, I'm here to pump you up. Okay, that fly's ridiculous. Anyway, so sine has to be positive, right? But sine represents what two numbers?
There's 2 of them.
It's y over r. And what do we know about r? R is always
Positive.
R is always positive, right? R is always positive. R is always positive. So now, for sine to be positive, what do you know about the y? Is the fly just got everyone distracted here? Think about it. Think about it. Sine has to be positive. If R is always positive, is it possible for the y to be negative?
No, because then it would be a negative.
Then the whole thing would be negative, right?
Yeah.
So therefore, given that much information right there, that sine has to be greater than 0,
You know that.
sine has to be positive, y has to be
Positive as well.
very good. I'm going to put a plus sign right there because that's what I need from that. Now, let's go ahead and do my Pythagorean theorem again. So, I'm going to have negative radical 3 squared plus y squared equals 4 squared. When I square that, what's going to happen to the negative and the radical? Gone. 3 plus y squared is, what is 4 squared?
16.
Subtract 3 from both sides.
13.
Y squared is
13.
y equals plus or minus the square root of 13.
But wouldn't it have to be positive though? It wouldn't be negative because.
Very
it's-
good.
Yeah.
But there is a possibility, and that's why I'm writing down this possibility in my work. And that's why I went back over here at the beginning and I'm like, hey, sign has to be positive. So I'm going to make that one a positive right there. So that's got positive rad 13. Yes?
Yes.
Okay. So do we know how we know all of our x, y's, and r's now, right? Say yes.
Yeah.
Okay, good. Let's write them all out. So I gave you cosine, so let's start with sine. So when x was negative radical 3, y is positive radical 13, and r
4.
was 4. So let's go ahead, and if you notice, each time I'm doing this problem, I'm writing down, I'm listing my x, y, and r, and then I use that table from the 1.3 that I gave you, the little thing that had all your x, y's, and r's listed,
Yeah,
just
so
plug them in.
Sine is y over r, so it's gonna be rad 13 over 4.
Very good. And we did cosine, so next one's going to be tangent.
Tangent is, yeah.
Y over x, very good. So my y, rad 13 over x, negative radical 3.
Would you have to,
Yes.
rationalize that one? Okay, so you have to multiply both sides by, negative rad 3.
I don't need the negative, I just need the rad 3.
Oh, you said the rad 3.
Yeah, so the negative could just go out front, because I know that the whole thing together is going to be negative, right?
So you have to multiply by, just like rad 3.
Yep. And if I'm multiplying radicals, what happens?
But you just add them together.
Not add them together, I multiply the insides together.
Oh, okay, so it would be rad 39.
Yep. So negative radical 39 over,
3.
there we go. And what's after that? Next one, let's do cotangent. Cotangent is, very good, negative radical 3 over rad 13.
Oh, yeah.
It's cotangent, right? Or did I say the wrong thing?
You got it. No, you got it.
Okay. All right, so right there, again, rationalize.
I used it. That's what I heard. That's why I said 4.
Okay, so negative radical 39 over 13. Secant? Yeah, cosecant, or secant. Let's do C. Cosecant is R over y. So that's going to be 4 over rad 13. Now this one here, I'm going to rationalize, but I have a rational and a non-rational. So when I rationalize, I just put those together because I'm multiplying them. But since they're not radicals, they're both not radicals, I can't multiply them inside together. So I'm going to come up with it being 4 rad 13 over 13.
Abraham, stay still. Watch him. He's on his back.
No, I'm not going to, because you'll have like this nasty fly mess on you. Okay, because that's messed up, right? Do you really want to walk around with dead fly all over you? That's like all we do right now.
He got a fly on your notebook.
I actually got him that time too.
Oh, did you kill it? Okay, so that's the.
I know, right?
That's the end of the fly problem.
I know, right? Okay. All right, for all those people following along on YouTube, yes, damn it, there's another one! All right, so what are we missing? We got cosecant, so we need secant, thank you. So secant theta. So secant is r over x, so that's 4 over negative radical 3. Rationalize, rad 3 over rad 3.
4 rad 3 over.
Negative 4 rad 3 over 3. I always move the negative up to the top whenever we're doing this, or out front. A lot of people have trouble identifying a negative from a minus sign. So as you're writing it, okay, if you left it on the bottom, it's fine. If you move it up to the top, it's fine. But when you're doing some of these problems here later on, you're gonna have to identify the difference in between a negative and a minus, because they will ruin your day. Bam. All right, so this one says only sine and cosine. Sine and cosine. What time? Is it break time?
It's 9:03.
Yeah, let's pause this right now. Stretch, because I can't talk for so long. And then I want you guys, because people are trying to zone out and trying to do their makeup. So I want to give them time to finish. All right, so I'm going to pause this and then we'll come back.